Relay Setting in Differential Room Part 1. In AMT differential room, differential relays and longitude differential test is performed. Differential relay works by comparing the currents in both sides of the equipment and measure and compare the current in both sides of the protected equipment, which is used to protect power transformers, motors, generators, and bus bars. Note that to perform this test, both current group A and B are activated, and if you intend to use neutral cable for the test, you need to select Current as Combination Cable in Preferences section in Hardware section. Differential room consists of two main windows of Test View and Differential Characteristic. In Test View window, shot, check, search, and stability tests are performed. In Differential Characteristic window, the relay characteristic curve is displayed according to the information entered in test object based on I-bias and I-diff. As mentioned before, to test a relay, first it is necessary to enter its information in Test Object window. In device block, information such as relay nominal characteristics, serial number, location of the relay, as well as CT and PT characteristics of the relay are entered. This section has been thoroughly explained in previous videos. Differential is the main block of this room, by double-clicking on which Differential Protection Parameters window opens. This window consists of Protection Object, Protection Device, Characteristic Definition, and Harmonic tabs, where the settings of differential relays are entered. Protected Object tab. In Protected Object tab, the information related to the protected equipment is entered. In Protected Object field, first the type of the protected equipment is selected among transformers, generator, motor, and bus bar, and here transformer is selected. In Vector Group section, the transformer vector group which is entered in Nominal Value section is displayed. In Number of Windings section, the number of windings of the transformer is specified. If the transformer has 3 windings, a column named Tertiary appears in which the information of the third winding is entered. Here, 2-winding transformer is selected. The Nominal Value section, the nominal information of the transformer is entered in primary, secondary, and tertiary columns for primary, secondary, and tertiary sides, but since here the transformer has 2 windings, the tertiary column is disabled. In Winding Leg Name row, it is possible to enter an English or Persian custom title for the winding. In Voltage Power Vector View and Connection Number fields, the nominal voltage of the 2 sides of the transformer, the nominal power of the transformer, connection type of the 2 sides of the transformer, and vector group number of the transformer are entered respectively. If there is a null point in the star direction of the transformer, select Yes in the star point grounding field. For example, if the transformer vector group is YND11, after specifying the transformer wiring type in vector group and its vector group number in connection number, in star point grounding field, Yes is selected in the primary column. In current field, the nominal current of both sides is calculated by the software based on the entered voltage and power, which is not editable. In delta connected CT field, if the CTs are wired in delta form, Yes is selected, otherwise No is selected. Then, in CT nominal current section, nominal information of the CTs in both sides of the device are entered separately. Note that for this section, the differential and bias current calculations are done according to the calculated current and the entered turns ratio, but if from View menu, primary is selected as unit primary currents of both sides of the transformer in vector view are displayed according to the CT turns ratio entered in device block. In a star point grounding section, the turns at which the null point of the CTs is located is specified. If the null point is located at the protection equipment side, toward protected object is selected, otherwise toward line option is selected. Protection Device tab. After entering the characteristics of the protected equipment in Protected Object tab, it is necessary to enter the relay characteristics in Protection Device section. First, I-bias formula is entered from I-bias calculation field, which consists of 7 main formula. One of these formulas should be selected from the relay manual, and factor K1 is entered based on the selected formula. Generally, the characteristic curve is different for single phase and multiple phase faults, but by checking No Combined Characteristic option, the differential characteristic curve will be the same in single phase and multiple phase faults mode. After drawing the characteristic curve, the complementary explanations are provided. In reference winding field, the direction of the reference winding is determined, which is selected in accordance with the relay settings. By selecting the reference winding direction, the angle in that end is considered to be 0. Since differential and bias currents are calculated and displayed based on the nominal current, it is necessary to select the nominal current of the relay among CT and nominal current of the protected equipment in reference current. For example, if current protected object nominal is selected for reference current and IDIF to IN, IN is the nominal current of the equipment whose information is displayed in protected device tab, nominal values section, and current field. But if CT nominal current is selected, IN is CT nominal current whose information is entered in protected device in CT nominal values section. In zero sequence elimination, if the related relay supports zero sequence elimination in measurements, you can select the zero sequence elimination type in elimination type field. This feature has been put in relays so that if there is a phase to earth fault outside the protective zone, the existence of zero sequence current does not stop the relay. However, this makes the relay less sensitive to phase to earth fault. And to compensate this, restricted earth fault protection is used. In test time setting transformer model, test max and delay time fields specify maximum time of fault current injection and delay time after receiving trip contact, respectively. In diff current setting, IDIF first stage field is related to first stage and IDIF second stage is related to second stage. Note that for currents lower than IDIF first stage, for every bias current of the relay is stable and does not perform a trip, but currents bigger than IDIF second stage indicate a fault near the transformer wiring and the relay performs an immediate trip without considering the bias current. But between IDIF first stage and IDIF second stage currents, the relay operation is based on the characteristic curve and there is no delay in the operation. In current tolerances, you can enter the current tolerances in two forms of relative and absolute. Note that the software takes into account the highest value between these two. In diff time setting, TDiff field is the allowed operation time of the operation zone between IDiff first stage and IDiff second stage, and TDiff is the differential currents bigger than IDiff second stage. In time tolerances, you can enter the current tolerance in two forms of relative and absolute. Note that the software takes into account the highest value between these two.